What's up, Algebros? In this video, what we're going to do is solve a problem related to inverse variation. It says here, suppose that the demand D for a candy at a theater is inversely related to the price P. Part A wants to know when the price of candy is $2.25 per bag, the theater sells 168 bags of candy. It wants us to provide the demand for candy in terms of its price. So what that means is we're going to have to form an equation based on that information. And the equation should also be based on inverse variation. And then for part B, it wants to know the number of bags of candy that will be sold if the price is raised to $3 a bag. Alright, so let's get rolling with part A's solution. I'll do this in kind of a conveyor belt type process. The first thing that I would encourage you to do is just to come up with a general formula for your model. Do keep in mind that it says that the demand and price are inversely related. So generically speaking, the equation you'd use for that is y equals k over x, where x and y are going to be replaced by the variables for the two quantities being measured here, and k is called the constant of proportionality. Now, it does want us to use d and p instead of y and x, and let me give you a trick as to how you'll figure out which variable gets replaced by what. Whatever is to the left of this keyword inversely, in this case that variable would be d. This is what you replace y with, and whatever's to the right of the key verbiage here, in this case the variable p, that's what you're going to replace x with. So y equals k over x. Okay, y is going to get replaced with capital D, k will be left alone, but x will get replaced with lowercase p. That takes us to the next part of this conveyor belt solution, where I recommend finding k. And the way to do that is to use the information given in the first sentence of part A. So for example, it says when the price of candy is $2.25 per bag, the theater sells 168 bags of candy. Well, 225 is a particular value of P, and the number of bags the theater sold, 168, is a particular value of D. That's how much the people demanded at this price. And what you're going to do is kind of fold this into our equation or our model that we just tweaked with the variables d and p, and that'll allow us to solve for k. So I'm going to replace d with 168. We'll leave k as is, and underneath k we're going to divide it by $2.25 or 2.25. Now you can multiply each side by 2.25 to solve for k, which is what we want to do. And when you do so, you're going to get k is equal to 378. So now that we have k, we can be a little more specific about the model that we got in the first part of the solution. So that brings us to the third part of this conveyor process, which I like to call the rewrite part. And basically what we're going to do is we're going to blend together our answer from the model part of the solution and also the find k part of the solution. In other words, I'm going to replace k in our model with this value of 378, leaving d and p alone as variables. So for part A, it says write the equation that relates d to p. This is exactly what it means. Okay, write the inverse variation equation using the specified variables and also the particular value of k you'd get using $2.25 as the price p and 168 as the demand d. So d is equal to 378 over p. Part B, again, determine the number of bags of candy that will be sold if the price is raised to $3 per bag. This is going to add sort of like a fourth layer or fourth step to our conveyor belt solution, which I like to call the use part. So it says in part B that the price is raised to $3 per bag. So this is a particular value of P again. So we'll say P equals 3. And it wants us to know how many will be sold. So we're not given a value of D in this part of the question, which that's okay. We have a formula from part A that will help us determine this. So we'll leave D as is, we'll leave 378 as is, but we're going to change P to 3. And when you crank out the arithmetic here, you should get 126, meaning that 126 bags of candy are sold if you raise the price from $2.25 to $3. So obviously this is a little bit less of a demand, and hopefully that makes sense. I'm sure you've experienced in the real world the idea that, you know, when the price goes up on stuff, the amount demanded tends to go down. Heck, we experience that in theaters nowadays, right? I mean, isn't that the reason why we go to the dollar store and stuff our pockets with candy and just kind of sneak it into the movie theaters? I'm just kidding about that. But anyway, so 126 is going to be what we're going to fill in this blank with. So completed, it says the theater will sell 126 bags of candy if the price is raised to $3 a bag. Alright, and that's where the pain and torture, sorry, fun and excitement for this video ends. Of course, if you have any questions whatsoever, let me know. Otherwise, thanks for watching, and stay awesome.